This lesson is about measures of center. First, I want to introduce the idea of a statistic. So a statistic is a value that is calculated from a set of data. So instead of looking at the entire set of data, you look at a statistic that represents something about that data. Statistics, plural, will be multiple values that are calculated from a set of data. So we are now going to learn three statistics that are measures of center of the data. The first is called the mean, and the mean is just your ordinary average. So basically you add up all the values and you divide by the number of values. Now the x1, x2, x3 are the individual values numbered 1, 2, 3, so we can tell them apart. And then n is usually for the number of values that you have. And the mean is written with sigma notation this way. The sum as I goes from 1 to n of x sub I, so x1 plus x2 plus x3 to xn, all divided by n. But of course, all you're just doing is adding up all the numbers and dividing by the number of numbers. Now, there are two variables or symbols that are used to describe the mean. One is x bar, which is usually done for a sample. So x bar is the mean of a sample. And the other is mu, which is a Greek letter mu, and it's usually the average or the mean of a population. So x bar is for a sample and mu is for a population. Both of them represent the mean of the data. The next statistic is the median. The median is the middle value of an ordered set. So first of all, you must order your set. That's important. Usually that means increasing order. So that's going to be your first thing that you need to do. Then you're looking for the middle value. Now, the middle school way of doing it would be to cross off on either end, but we are way more sophisticated than that. We will no longer be doing that, and there will definitely be scenarios where that isn't even possible. So what we do is we find the n plus 1 over 2th value, n being the number of values in the set. So if n is an odd number of values, let's say 21 values, then n plus 1 becomes 22, and then divided by 2, that becomes 11. So you will be able to find the 11th value of the set. So if there's an odd number of values, you actually find a value from the set, and that is your middle value. Now, if n is an even number, let's say 30, then 30 plus 1 is an odd number divided by 2. Well, that's 15.5. Well, there is no such thing as the 15.5th number or value in the set. So what you do is you find the 15th value and the 16th value and you average those two, and that becomes the quote-unquote 15.5th value of the set. And then finally the mode. The mode is the value or potentially values that is the most frequent. Now, there are a couple things you need to remember about mode. You could have multiple modes that are the most frequent, and they tie for the most frequent or the most popular. Or you could have no mode at all if every single value occurs exactly once. So none of them is quote-unquote popular. So you could have no mode if every data value occurs once, or you can have multiple modes if there's more than one that are tied for the most frequent. So that's mode. Now, modal class, if you've separated your data into class intervals, then the class interval that is the most frequent becomes the modal class. And again, you can have multiple modal classes or no modal class if every single class interval occurs exactly once. However, if every single class interval occurs exactly once, then you probably have not separated your class intervals appropriately, because if you remember, you want to do approximately square root n number of class intervals, which means there should be multiple data values or higher than one frequency in some of your class intervals at least. All right, here's an example. The number of items returned to a store each day over 21 days are, and then here is the list of 21 values of numbers of items that were returned to the store. We want to find the mean, the median, and the mode. Now, before we do that, this data is not in increasing order. So regardless of what calculation I'm going to do, it's helpful to have the data in increasing order. Now I've rearranged these 21 data values into increasing order, and here they are. Now, For the mean, it may seem like that is a waste of time, but even for the mean, it is helpful to have rearranged them into increasing order, because here is my calculation for the mean. I'm going to use the X bar symbol. I want to add up all the numbers and then divide by the number of numbers. In this case, there were 21 numbers. So I'm going to add them up and then divide by 21. And I'm not going to write 1 plus 1 plus 3 plus 3 plus 3 plus 3 plus 4 plus 4, etc. I'm going to write 1 times 2, because there were 2 1s, plus 3 times 4, because there are 4 3s, plus 4 times 3, because there are 3 4s, etc. So the fact that I put them in increasing order makes it easy for me to tell how many of each value there was. And so I can it's quicker for me to calculate the sum. I don't have to actually add all of the values up, because I can do repeated addition by multiplication. Anyway, so here's the calculation, and the final answer for the mean ends up being approximately 5.38. So there's the mean. Just so we have it for later, I'm going to write the sum, which was 113 and then over 21, and that's how we calculated the 5.38. Now let's do the mode next, because it's quick. So the mode is whichever one occurred the most. Well, again, by putting them in increasing order, it's really easy to tell if there were 4 3s and none of the other values occurred as many as the 3s, so the mode is the number 3. And again, the original data, that would have been a pain to try to figure out which had the most, which occurred the most. Now for the median, I'm going to do the n plus 1 over 2th value. Well, n was 21, so 21 plus 1 over 2th value. Well, that becomes the 11th value. So that means I need to count out till I get the 11th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this 5 right there is the median. It is the 11th value. And remember, the median is the middle value, which means there should be the same number of values on the left of it, the same number of values on the right of it. And if you count out, there should be 10 values to the left of that number 5 and 10 values to the right of that number 5. Okay, for part B, on the 22nd day, 9 items were returned. How does this affect each measure of center? So let's go ahead and calculate each measure of center. So to calculate the new mean, I'm just going to take the previous sum that I had before and add 9 to that. So 113 plus 9. And then instead of 21 values, now there are 22 values. And so that becomes 122 divided by 22, which is approximately 5.55. So it went up slightly from the previous value because the number that was added was a large number. So let's do the mode next. So the mode, well, what happened was the mode used to be 3 because there were 4 3s, but now there will also be 4 9s because we just included an extra 9. So the modes now are 3 and 9. Now for the median, I'm not going to put the 9 in at the end, but you can imagine there's a 9 there. So now the problem is the n plus 1 over 2th value. Well, that's now 22 plus 1 over 2th. Or in other words, 11.5th value. Well, there is no such thing. So what we do is we average the 11th and 12th value. Now, luckily, when we put that extra 9 at the end, it just stuck on to the end, so I don't have to rearrange any of the other values. This is now the 11th value, and this one will be the 12th value, so the average between the 5 and the 6, so the new median is going to be 5 plus 6 divided by 2, or in other words, 5.5. All right, 6 people have a mean mass of 53.7 kilograms. One new person with a mass of 60.7 kilograms joins the group. What is the new mean mass? So the X bar so far is 53.7, but there were 6 people. So the total mass beforehand was 53.7 times 6, which is 322.2 kilograms. Now the new X bar, well, I need to add up all the masses. Well, I know what the previous total mass was. So it's 322.2 plus the new person joins in with the mass of 60.7. And now divided by the total number of people, well, in this case, now there are 7 people because there were 6 before and 1 new person joined. So this is 382.9 divided by 7, which ends up being 54.7 kilograms. And that's the end of that one. Now let's talk about some properties of the mean, the median, and the mode, because sometimes you want to choose what is a more appropriate measure of center for your given data. Sometimes you report all of them, but there are some advantages and some disadvantages of the various measures of center, or the statistics of center. So here are some pros and cons, or some things that you need to think about. So for the mean, the good thing about the mean is that it's commonly used and it's easy to understand because it's just an average. People are used to doing averages. That's not a new thing. They do it all the time. The other advantage of the mean is it takes all the values into account. It just does not ignore any of them. Every single value gets counted out when you add them all up. However, it is not resistant to extreme values. When you put in another extreme value, or if you have an extreme value in your data set, the mean is going to get pulled towards that extreme value. So for example, if your data set is negatively skewed, then your mean is going to get pulled towards the negative direction, towards the lower end of your data. It's not going to reach that lower end, but it's going to get pulled that way more than some of the other measures of center will. The median, well, the median gives the halfway point of the data, which in a lot of scenarios is very useful. So for example, if you ever look up when countries or towns or states or whatever, or even companies want to describe the income that people get, the typical, let me call it that, the typical income that people have in that company or town or city or whatever country, they will report the median income rather than the mean income. This is more obvious in a company. So for example, the CEO and sort of the big shots in the company are probably going to be earning a lot more than the average worker who, works in the factory or who works in the office or wherever it might be. But the median income is a more useful measure of center for people to look at, because it then kind of does not get pulled by those extreme values. So anyway, it gives the halfway point of the data. However, it only takes the middle values into account. So that's something to be aware of. It may or may not be a good thing. There are scenarios where it is helpful, but it is resistant to extreme values. So like the example with the income that people are getting. If you have a CEO that earns millions of dollars, the median doesn't get pulled in that direction. The median still basically stays in the middle of the data set. So it's going to be a better description of the typical income that someone will expect to get at that company. So it's resistant to extreme values. Finally, the mode. Well, the mode gives the most common value, which sometimes might be helpful. It could also be most common values. However, it ignores all the other values. It only looks for the most common. Doesn't matter where in the data set that is. It's just looking for the most common, so it's ignoring everything else. But it is resistant to extreme values. So, because extreme values typically are less frequent, and therefore the mode is not going to look at them. So those are some advantages and disadvantages, or properties, if you want, of the mean, the median, and the mode. All right, so here is a bar graph, I suppose. I didn't give you exact values here, but it's a bar graph representing whatever values you have in your data and then some frequencies for those values without any numerical numbers actually put in there, just sort of a graph of it. The arrows are the mean, the median, and the mode, and the question is which one is which. So first of all, the mode is relatively obvious because it is the most frequent, so the red arrow must be the mode. Now, remember the mean is going to is less resistant to the extreme values. So there is this extreme value here. In fact, this is skewed to the right or skewed positively. So the mean is going to get pulled towards that skew or towards that extreme value. So of the two remaining values, the yellow one is going to be the mean, but because it is going to be affected more than the median will. So the yellow is going to be the mean. And then finally the green, which is not going to get pulled as much towards the extreme values or toward the right skewness in this case, that one's going to be the median. Now the mode is not always pulled the least. It's just wherever the peak, the highest frequency. Could have been here, could have been anywhere. The mode can be anywhere along the data set. It's not necessarily going to be pulled the least, but in this particular example it was. The comparison really is between the mean and the median. The mean will always get pulled towards, it's less resistant toward the extremes, whereas the median is going to be more resistant toward the extremes. And that's the end of the lesson.